We're going to talk about Puppet. And I've been doing Puppet since 2011. We migrated our servers back then on a new infrastructure and a new data center with more servers. And I didn't want to do all this hassle with setting it up manually. Back then it was like 7 or 9 servers. And this is why I started looking into Puppet. And I've been doing it since then, and I really enjoy it. Who of you already used Puppet? OK, that's good. You might learn some new stuff as well, but I'm not sure about that as well. Who of you uses Vagrant? Nearly the same. Good. Anyone tried out Chef? Those are different people than the Puppet people. That's nice. OK. Someone used CF Engine? Well, you weren't in the Solid talk, right? Because they asked as well, and everyone laughed. At least I did. I'm sorry for using CF Engine. Are you software developers? Who is a software developer here? Nice, nice. So you obviously use a version control system like Git and Subversion or Mercurial, or I don't know how they were called a couple of years ago. Who of you uses it for infrastructure like server configuration files? Quite more than those who used Puppet and Chef. I'm not sure if you just store the config files there or have some other system up and running, but at least some of you already do that. There are so many software developers who kind of are responsible for setting up and configuring servers as well. And they always use version control systems with their source code, but they don't do it with the servers. And this is something that should be changed from my point of view. And this is a place where Puppet can actually help us. Before we start with the content, one little note. If you have any questions, just interrupt me immediately and ask them at that point. Don't save them for the end, because I don't have that much time to stay here because of my flight. I already mentioned that. And in addition, I won't know what I was talking about half an hour ago. So just interrupt me immediately. Let me tell you something about the agenda. At first, I'm going to introduce you a little bit to Puppet and tell you some blah, blah stuff, like where it came from and so on. Then I'm going to show you some examples of what you can do with Puppet and how you do it with Puppet. Then I'll introduce you to Vagrant, because it said maintaining your environment, and the environments of a software development company always means your production environment for sure, maybe testing, staging, hopefully testing and staging, and the development environment. That's where Vagrant comes into play. And at the end, I'm going to try to show you some more advanced Puppet stuff. It really depends on how long it takes me to get there, how much I can go into detail there. The last stuff will be some last hints. I always do that at the end of my talks. I just throw some words at you and give you a short explanation, but this is stuff that you might want to Google at home, and I can't explain that much detail here. OK, let's get to Puppet, and yeah, let me show you what we're going to talk about. Puppet is something like this, where you control some puppets, and you're a puppet master and stuff. And we're also going to talk about chocolate here. I'm sorry, I didn't bring chocolate. I always want to bring chocolate to this talk, but I always forget it. Sorry. And we're also going to talk about this tweet by Dean Wilson, which says, do you know what we call adding monitoring to over 30 websites, 10 servers, and over 50 services on those servers? A Puppet run. And at the end, I'm going to tell you or show you how you can actually do this with Puppet totally easily. And every new server that pops up will automatically be monitored. But before we get to that, it's going to be a little bit dry. I'm sorry for that. Because I'm going to tell you some history about Puppet. Or not history, but explain what it is. Puppet is a configuration management software, which means its purpose is to modify configuration files of services, of software you installed. In addition, it's able to install software, remove software, and do some other fancy stuff like managing services and yeah, everything you can imagine. Puppet is open source, but there's also a commercial version which has the same features as Puppet, plus some more tools, which some of them are closed source. But the major aspect of this Puppet Enterprise is that it's all integrated, and you don't have to take care of integration of so many services. It's probably really nice, but I haven't used it yet. Puppet is written in Ruby. I think it's important to mention this at a PHP conference. I think there's no alternative to Puppet which was written in PHP, which is weird. PHP developers tend to rewrite everything in PHP, but they didn't for Puppet as far as I know. And it's not really that bad that it's written in Ruby because the Puppet manifest, the source code that we write, is not written in Ruby. That's a difference to Chef, where you have to write Ruby code all the time. I don't really like Ruby. I already developed some Ruby code, but I don't really like it. And it was one of the decisions for me to choose Puppet over Chef, because if I have a full programming language like Ruby, I could, in my configuration management source code, for instance, use Active Record and access a MySQL database. And I don't really want to do that. And it's pretty nice that Puppet prohibits me from doing that. So this was one of the only differences from functionality that I saw between Puppet and Chef back then. So most of the stuff that I'm going to tell you here could be applied to Chef as well. It's just a different syntax. And it allows you to do some more stuff. You can write plugins in Ruby for Puppet. I actually already did that. They were like copy-paste adapt code. So I copied something from one plugin and changed a little bit of it, and then it suddenly worked. I still don't know how to do Ruby, but I developed Puppet plugins. That's pretty nice. But I'm also going to show you a way on how you don't have to write Ruby code in a situation where you would normally write a Puppet plugin. Puppet can be run in a one-node setup, which means you deploy your Puppet source code on a machine and tell Puppet, please execute this source code. But in addition, you could also have a multi-node setup, a so-called master agent setup, where you have this single node which is responsible for handling the configuration of all other nodes. This is the so-called master. Some companies even use the one-node setup in a big cluster. So they have, for instance, Debian packages which distribute the Puppet source code to all nodes and then execute it locally. But you lose some features if you do that. You don't have a single point of failure in that case, which might be nice, but you lose some features. I would always suggest going the master agent way, unless you have too many nodes and you can't scale your master anymore. One important thing about Puppet is that it's that if you write Puppet manifests, though you write it in a declarative way, compared to imperative or whatever. So you don't say like apt-get install Apache, but instead you say here should be an Apache installed. And oh, I got notes about that. So you describe the state that should be achieved, and you don't describe how to achieve that state. For sure, there are some exceptions where you have to describe the actions, but most of the time this is true. And Puppet's job is to ensure that this state is the current state of a node. So this is what Puppet basically does. There's another very, very important concept in Puppet that is idempotency. Who of you knows what it means? Okay, idempotency is some mathematical term, actually. It means that it doesn't matter how often you execute an action, the result should always be the same. For instance, doing a GET request on a website should be idempotent because you always get the same result. But if you append something to a file, then that's not idempotent, because if you do that twice, it's going to be twice the size. The file is going to be twice the size. Again, if you write some content to a file and overwrite it every time, that would be idempotent again. The same applies for everything you do in Puppet. It should be idempotent. And this is actually pretty nice, because that means you can run Puppet all the time, like every 5 minutes, every 30 minutes, every 30 seconds, if you have that much CPU left. And Puppet will always ensure that this state is present. So if one developer logs into a machine and types something, modifies something, Puppet's going to immediately overwrite it. That's way nicer than if it would like never do that and you wouldn't realize that something was changed. Enough of that, blah, blah. Let's get to some real code. The first thing I always try to teach people about Puppet is how to install a package, because that's the thing you have to do when you want to set up a machine. If you're on a Debian or a Ubuntu machine, you normally do like apt-get install Apache 2 or maybe aptitude install Apache 2, whatever, if you want to install an Apache 2 web server. With Puppet, you do puppet agent apply apache2.pp. This is actually a one-node setup. This is what you would do in a one-node setup. If you have master agent setup, this all is a bit different, but for getting started, the one-node setup is totally fine and it's way more easy. So apache2.pp is actually a file name, and this file has to have this content. We define a so-called resource of the type package, give it the name Apache2, and say, please ensure that this package, this resource, is present. And if we run this now, Puppet is going to install an Apache 2, the Apache 2 package. If you would run it again, it wouldn't install it again because it would check, is there a package? Yes, it is. Is that package installed? Yes, it is, so don't do anything. That's important for this idempotency. Maybe one of you uses Red Hat. And on Red Hat, if you want to install Apache 2, you have to say yum install httpd instead of yum install Apache 2. I don't know why. No, actually, I do know why, and it makes sense, but it's weird in the first moment. If you want to use that with Puppet, you have to do this. Again, resource package, the name httpd, and show present. So Puppet is a wrapper, provides a wrapper for this yum or apt-get, but it doesn't provide a wrapper for these package names. You might want to ask, what if I want to support both Red Hat and Ubuntu? Then you can use a switch case statement, for instance. And I introduce another concept here. I introduce the concept of variables. I create a variable web server package name, and then I do a switch case in this funny syntax and say if operating system is Ubuntu, use Apache 2. If it's Red Hat, use httpd, and the default should be Apache 2 again. And this variable can in turn be used as a name for this package resource. So this manifest would actually work on Ubuntu and on Red Hat. So the question was, if Puppet uses aptitude or apt-get or yum, you normally get questions during the installation process. And how does Puppet handle that? And the real answer would be it kind of ignores it. It passes a flag that all questions should be answered with yes. So this works out quite well, actually. I never experienced problems with that. I had experienced problems with some package. I think it was the Oracle JRE or something, which has a license agreement question, which is kind of different, kind of weird, and Puppet failed for that at first. But I figured out a way how I could tell the system that I already acknowledged the license, and then it worked as well. And you also asked that, or mentioned that these package managers suggest installing other packages, and this is something that Puppet completely ignores. It doesn't install suggested packages. It does install dependencies, obviously, but not the suggested ones. Because if you want to have them, you have to tell it to Puppet on your own. I'm repeating the questions for the camera, by the way, because someone looked a bit confused. Is that okay as an answer? Okay, fine. I might want to ask, where does this operating system variable come from? That's actually something where Puppet leverages a different tool called Factor, which provides facts about nodes. So you can run this on every node where you install Puppet. There's also Factor automatically, but it's a separate tool. And it describes the current node. So for instance, it describes the operating system. And all these facts are automatically available as variables in Puppet. But you could also access them using a command line tool, which is just called Factor. And if you call Factor on the command line, you do like this, and then you wait, and then you wait, because it's for some reason incredibly slow, maybe because it's Ruby, I'm not sure. And then at some point you get this output and some more lines, but the slide was too small. And right here we find operating system equals Ubuntu. And we also get some other information like the dist code name and the release version. So if we have to distinguish within our Puppet manifests the release of, for instance, Ubuntu or whatever distribution you use, they all have releases, then you can use these variables. And actually, until I did this talk like a year ago at some conference. I said, on an Ubuntu system, I don't know how to figure out which version it is. And I'm so happy that I have Factor now and I can ask it that way. Someone told to me, oh, there's etc issue, it says that as well. No, I'm happy about that. But at first, I really liked it to figure this out. You can also see there's like the IP address, which is totally useful, or you can see if it's a virtual machine and so on. So much about Factor at this point. There's one important note about the Puppet manifest. The Puppet manifests are those files that we just wrote. And when you work with Puppet, you really have to understand that you have to treat them as source code. You have to do everything you do with your every other source code, you have to do with the Puppet manifest as well. This means, for sure, version control. It most likely should mean automated testing as well. And it means code review and whatever else you do. You should do that with Puppet manifests as well. There's a tool, Puppet lint, which checks if the file is valid. There are also some IDEs out there which support you in writing Puppet manifests, and nearly every IDE or editor has syntax highlighting, at least for Puppet. So it's actually a tool that is quite a couple of years old now, so there's some kind of ecosystem already. Does that answer your question, or did you want to go into another direction? Okay. We just created one resource, so everything's fine. But as soon as we start defining more than one resource in our Puppet manifests, at some point we'll figure out that these resources are not applied in the order that we write them down. This actually makes sense. At the first point, you think, why the hell would they do that? But you have so many dependencies between different resources that you couldn't order it sequentially and still understand what you're doing. So it's really nice that Puppet doesn't do it this way, but instead you can define dependencies between resources. And this is what we're going to do here. We have, again, this package web server, the package for the Apache 2 web server or whatever web server we use. And we say, please ensure that it's present. In addition, we're going to create the config file of our of our light HTTPD web server in this case. And we use the file resource for that and say this file should somehow be handled by Puppet. And actually, we say, please ensure that it's present and that the content is foobar. If we would now run this manifest and Puppet would for some reason decide to evaluate this resource before this resource and the package is not yet installed, Puppet is going to fail because this directory doesn't exist. So what we have to do is we have to say this resource, the file resource, requires the package resource with the name web server package name. Actually, you might have noticed this capital P there. This is actually on purpose. In Puppet, if you create a resource, you write everything lowercase. As soon as you reference a resource somewhere, you have to write the first letter big as a capital. I guess that's because someone didn't know how to write a parser or something. I got no sane reason for that. Sorry, you just have to live with it. I just showed you how to create a file and write some static content into it, but that's quite boring, and I'm going to show you something that's a little bit more interesting. This was the example we just had, but instead of just writing static content in there, you could say, please use the file temp foobar as the source for this light HTTPD conf. And we can, again, use variables within this string. For instance, the fact of the host name. This would allow us already, if we have several machines and several light HTTPD config files for this, to store them all in one directory and give them a name depending on the host name. This is a bad practice. I'm just going to show to you how that it could work this way. Those of you who attended the talk about solid architecture and stuff, no, solid infrastructure and stuff, they showed it as well. That's really not the way you want to do it. I'm going to show you how you want to do it later. In addition, you can manage services with Puppet. Despite of files and packages, there's also services. If we do this, Puppet will make sure that the service with the name light HTTPD is currently running and that it's enabled, which would mean that it starts at boot up of the system. Puppet can handle this for like all the important Linux distributions, and in some way, somehow, and I don't know, with Windows as well. But I know nothing about the Windows support of Puppet. I just read about it with services. We would also have to create a dependency, obviously, to the package, because otherwise the service would try to be started without the package being installed, which wouldn't work out. But there's actually something that's a bit cooler about dependencies than what I just showed you. Did one of you ever change a config file and forget to restart the service afterwards and wondered, why is it not working? Why is it not working? Why is it not working? Yeah, I did that. I don't know how many times. And actually, when I started looking into Puppet and Chef, when I realized this feature that I'm going to show you in a minute, that was the moment where I was like, oh, I want to have it. Because Puppet helps us to not forget that. Let's imagine we have this package light HTTPD again, and we have a service light HTTPD, which requires the package. And we also have a config file. Then we can add, we have ensure present content foobar, require package, notify service light HTTPD. This means that whenever this resource is changed in some way, it's going to try to restart the service of light HTTPD. This means if you, for instance, change the configuration within your Puppet manifests, deploy the Puppet manifest, and the server evaluates the new manifest, it's going to automatically restart light HTTP. For sure, you have to think of this line, yes, but you only have to write it once and not every time that you modify the configuration, which was totally awesome. Okay, now that we talked about that, I want to get back to the files, and I want to talk about templates. This is the way how you want to create different config files for different machines, not the hostname thing I just showed you. Puppet has this templating language, or uses this templating language, ERB, which is, I think, embedded Ruby. No, I got no idea. It's some Ruby templating language. And you can use it within Puppet and say, this file should have the contents that this template evaluation would return. And within the template, we can again use variables. For instance, we could use facts, but we can also use our own variables, which could be created by facts. I was actually already helping a couple of companies with their Puppet setups. And one mistake that nearly all of them did is they didn't understand this templating feature and instead created all the different files for all the different hosts, as I just showed. And this doesn't really make it maintainable because you do a whole lot of copy and paste because you have a separate config file for every machine. And if you want to change one value on all machines, you have to modify all these files. So you really want to use these templates. OK, I'm going to switch the topic for a second, and I'm going to talk about Vagrant. We're going to talk about Puppet again in a minute, but I want to just introduce you to Vagrant at this point. Vagrant is a tool developed by some cool American, which helps you to leverage tools like Puppet, Chef, SaltStack, and all these config management tools, and install a virtual machine for every developer on his computer that reproduces your production environment in some way, and which sets up all the services you need and configures them, and I don't know what else you have to do on a machine, on a development machine. And yeah, he developed it as an open source project, and at some point he founded a company, and then it suddenly had to be enterprisey, so it had this logo right now. But yeah, let me tell you what the purpose of Vagrant really is. And it solves a problem that we all know. Imagine you are a producer of chocolate, and you produce this awesome piece of chocolate, and then you ship it to the customer, and the customer looks at it and says, well, it's kind of broken, and then you look at it again, and it's like, oh, it's awesome, and then you're going to say, yeah, it works for me. Some sentence that really every developer used. I used it, I don't know how many times. I still use it when it gets to Internet Explorer 6, but that's some completely different topic. If you've never heard of it, there's some explanation of the Urban Dictionary on what it means. It's something that really every developer says, because you change the code on your development machine, you deploy to production, something breaks. And Puppet and Vagrant, the combination of both, helps us to make sure that this doesn't happen, because the developer has a kind of replicate of the production environment on his local machine. And this all is automated, and I'm going to show you how we use it in a second. and it's pretty nice. Okay, some words about Vagrant I already mentioned. It's for creating development machines. It uses Puppet and Chef. It works with VirtualBox and VMware and some cloud providers as well. So the VirtualBox integration is open source and free. If you want to use VMware, you have to pay like $80 per developer. And you also have to pay $80 for the VMware license per developer. So it's quite expensive, but it's a really big performance boost. And if you're a macOS user, VirtualBox on the new Maverick system is kind of weird, and VMware is working quite well. Vagrant is written in Ruby as well, and you can, again, extend it using Ruby, and I already did that as well. I've got no idea what that code did that I wrote there, but the result was what I wanted, so it's quite easy to extend it. And it's, again, open source. Let me show you a kind of a real-world example on how we use Vagrant and Puppet in our place, and what it means to set up a new developer machine at our place. The first thing you have to do is, after getting an SSH key and signing up at GitHub and stuff, you have to clone a repository which lies on our internal GitHub server, and it's like some Vagrant CSCNT. This is the project we work in. And after cloning that, you move into it and you call init applications. Init applications does nothing more than checking out a couple of other repositories that can contain our application source code. So it's not really that important. And then we do Vagrant up. And yeah, then we go and grab a coffee, because this is probably going to take some time. With us, it takes like 2 hours or something, but we don't have to do anything in that time. We can show that developer around in our office and introduce him to everyone and stuff. We don't have to care about that. And then we just open a web browser on this URL, something like port 8082, and some host name, and suddenly he's got our application up and running. And our application up and running means it installed light HTTP, PHP, MySQL, CouchDB, Couchbase, Elasticsearch, Redis, I don't know what else. So it installed a couple of services in 2 hours without anyone doing anything. This is something I really, really appreciate. But yeah, you might want to ask what just happened. At first, we checked out the Vagrant configuration. This was this Vagrant CSCNT repository. It also contained our Puppet configuration. Then we checked out the application source code. This was init applications. Never mind about that one. Then we did Vagrant up, and that downloaded a so-called Vagrant box. A Vagrant box is kind of a template for virtual machines within Vagrant. So it's, in our case, just an empty Ubuntu, I don't know the latest LTS version, but it's something like that. And it just downloads it and puts it somewhere, and then it creates a new virtual machine out of this template, and installed and configured a couple of services there, fetched a part of our production database, and then the developer was able to use his machine, which is totally awesome from my point of view. You might want to ask, why did that happen? And the answer is quite simple. We created a Vagrant file within the repository, and the Vagrant file looks something like this. You have this first line that does something. I don't know, it's Ruby. And then you say, please use the Vagrant box with this name. Actually, it's not an LTS in this case. And if you don't have that box already, download it from here. And also create a port forwarding so that the port 80 of the virtual machine is available as port 8082 in my hypervisor, so in my MacBook in my case. And we also want to forward the MySQL server in our case. And then we set up some shared folders. We give this shared folder a name, and then we say within the virtual machine, the folder that is on my hypervisor at this path should be mounted to this path. You can also set some config options that it's using NFS then, but yeah, you really want to do that because without NFS it's quite slow. Let me just finish that, and then I'll get back to you. Also, we tell it to use Puppet with this weird Ruby syntax again. We say this is your manifest file, and also fetch Puppet modules, which are third-party modules or our own modules from this path, and Vagrant will automatically mount these folders into the virtual machine. Then we just do some Ruby code. And actually, I didn't realize this until now, but I'm still using the old Vagrant file syntax here. It changed some time ago, but it's basically the same, just some other words and namings and stuff. And the answer is it doesn't. You have this command line on Windows as well. You have to do Vagrant up there. There's, as far as I know, there is no user interface, no graphical user interface for Vagrant these days.
So this stuff doesn't happen in VMware directly?
No, this is not happening in the VMware application. It's just on your command line, on your Windows R thingy. And if you type in CMD there and press enter, then you have some kind of a command line. At least that was a couple of years ago. And there you just have to say Vagrant up. It doesn't have to happen within VMware. Vagrant controls VMware and creates the virtual machine, shuts it, boots it up and shuts it down and sets up port forwardings and that stuff. The question was why it makes sense to use VMware here, because you don't have, in your production environment, you probably don't have Windows servers, do you? No. So it makes sense to give the developer a Linux or whatever machine you have in your production environment, in its development environment as well. And that's what we use VirtualBox or VMware for. There's another pretty cool feature in Vagrant, and Vagrant supports multiple virtual machines within one Vagrant file. So for instance, I could create this Vagrant file, which is kind of like what I did before. Here we say use this box, and then we use config vm defined foo bar buts, and we distinguish the host names and the IP addresses here. And at the end, we say, please use this Puppet file. And if we do Vagrant up now, Vagrant will create 3 virtual machines. And they are all going to use the same Puppet configuration file, so they're all going to look the same. They just have different IP addresses here and different host names. And if you want to get your development environment closer to your production environment, this is actually something you can use. We use this for testing out RabbitMQ, but if you say we have some problems communicating between our application server and our database server, and you want to reproduce this in development and come even closer to the production environment, you can create something like this, where you say, OK, I want one virtual machine called web, which is the web server, and we want one virtual machine called database, which is going to be the database server. Then you can do this with Vagrant as well. And we include the same manifest file here again. You might now wonder, why do they get different configuration then? And that is something where Puppet has the concept of nodes, where you can just say, OK, I have a node web, which gets package Apache 2, and I have a node database, which gets a MySQL server. And these node names are fetched from the host name of the machine. So at first, it checks, is the host name web, does this match the host name? Otherwise, does it match the fully qualified domain name? And I think something more it does here. And you could even use regular expressions here to say every machine that starts with web should get an Apache 2 installed. This is the way how you can distinguish different nodes within Puppet. This is actually the format you would use on your Puppet master as well. Or you use Hira, but I'm not really that much into Hira. I'm going to say some words about that later. So yeah, this is what you need on your Puppet master as well. So you're quite close to the production environment right now in your development environment. Before I get back to Puppet, there's one thing I want to say about Vagrant. Vagrant has this Amazon EC2 integration for some time now, which kind of allows you to reuse your Vagrant file and just say, I want to use EC2 now, and then type Vagrant up, and Puppet is going to start Vagrant is going to start a machine on Amazon EC2, configure it using your Puppet manifests, rsync the shared folder, so it's one way in this case, and also set up, no, I'm not sure if port forwardings work, but something like this works there as well. So if you, for instance, have some task that you want to try out in development that needs more resources than your development machine has, this is a way how you could leverage EC2 and EC2's performance here. This is just, I never used it. I know persons who used it, but I never did it on my own. OK, I could foresee that and we're kind of running out of time. And this is why I'm going to speed things up a little. maybe you won't understand every piece of what I just tell you in the next minutes, and you won't understand every line of code. The important part is that you understand the concepts and the ideas that I want to tell you. And yeah, what we're going to do now is we're going to dive a bit deeper into what Puppet actually could do and how you would want to structure your Puppet code. The first thing that I'm going to show you is classes. Puppet has this concept of classes which allow you to group together some resources. For instance, we could create this class light.httpd, which contains the package light.httpd, a file with the configuration, and the service definition. I left out the stuff we already talked about here. And then we can just use the class by writing this. And this is actually something you want to do. You want to group together the resources because you want to reuse them maybe. And yeah, that's something we do in software development as well. One note here, classes in Puppet are always singletons. They can always only be instantiated once. Actually, the only problem here is that they called it classes. It's no problem that they're singletons and can only be used once on a node. It's just the name that is confusing here. So for instance, a machine can have the class, I'm a web server, but it can't have that twice because it wouldn't make sense to install light.httpd twice. And this is why they only can be applied once on a machine. Another concept of grouping the source code you write, the Puppet source code you write, are modules. Modules have this directory structure. For instance, a module called light.httpd would be in the directory light.httpd, and there would be a directory manifests with a file init.pp, and in that we would define our class light.httpd, so the code that we just wrote. And then we can also add some files to that directory and use them using the file and source attribute I showed before. And actually, there's a special synth. I think I'm going to show that in a minute, sorry. And also we can add templates to the modules. And this allows us to encapsulate all the stuff that belongs to light.httpd into one directory structure. And we can even share that on GitHub, for instance. There are quite a lot of modules on GitHub already. If we now want to use one of these files, like this one, we can just write a file and show present source Puppet : / or maybe \, I don't know, modules light.httpd index.html. And Puppet will automatically check the so-called module path. We already configured it in Vagrant. And check if there's a module called light.httpd. And if there is one, it checks, is there a file within the files directory called index.html. And this works on master agent and on single node setup. So if you do this within Vagrant, it will just check on the module directory of the local virtual machine. If you do that on a Puppet master agent setup, it will ask the master, do you have a file with this name at this place? And the master will transfer it to the agent. Actually, this communication between master and agent is done using HTTP, especially HTTPS with client certificates, so everything's encrypted except for the NSA broke it, but it could kind of be encrypted in theory. And so you kind of have a secure channel between your agents and your nodes, and you can, in theory, transfer secure documents over that. If we would want to use files, we can use the same Puppet : / syntax. I already mentioned the module path for the PHP developers. It's kind of something like the include path. You can configure it and can use several directories and say, please look at first in this one, then in this one, then in this one, and it will just try out all these directories and look for a module with the name that you used. And you really want to do that. This is basically the content of the Solid talk, that you want to do this. They explain some more content, but this is very, very important. You want to use modules. Otherwise, you end up in files with a couple of hundred or 1,000 lines of code, and you never want to have a couple of 100 lines of code in one file. Modules are also kind of namespaces. So we can create a file called light.httpd service, and this would only manage the service of the web server, and we could use it like this. So it's just like the same. You just use the double colon here, and this service class would be stored here in the light.httpd module manifests directory. I want to get back to this quote with monitoring servers using Puppet. This is actually one of the cooler features of Puppet. When I understood this, I was even more happy with Puppet. If we want to achieve this, there are two things we have to do. At first, we have to annotate the servers that should be monitored. We somehow have to say this is a machine that should be monitored. And in addition, we have to configure the Nagios machine, the actual machine that does the monitoring checks. You could also use some other monitoring system. We use, I don't know the name, Ikinga, I don't know how to pronounce it, which is this Nagios fork. And Puppet comes with resources for Nagios, which makes it very nice to use that, but you can use whatever else you want to use. And the concept that I'm introducing now is the concept of so-called exported resources. This is actually taken from our Puppet code. We somewhere have this node definition appserv and regular expression, which says here should be a number, and .crossscan.com. And then we create this resource Nagios host, which gets the full qualified domain name of the server as the name. And also we set this address parameter, which is the IP address of the first network interface. And then there's this funny add thing. I don't know why they used these characters, but they used it. And this means that this resource is a exported resource. Exported resources are not going to be applied on the machines where they're defined. So on this app server, which is our application server, nothing happens with this Nagios host resource. But instead, it sends it to the Puppet master and says, I just exported this resource. Do whatever you want with it. And this is one of the places where you need a Puppet master. If you do a single node setup, this won't work. And if we're now back on our Nagios monitoring host, all we have to do is, this is the host name of the node, and then use this spaceship operator. That's the actual name. And you say, please import all exported Nagios host resources. You don't have to write anything right here. It's left empty on purpose. No, that's not true. I wrote this one here, right? Whenever one of these exported resources change, restart the Nagios server, or Ikinga in our case. And this means all we have to do to monitor all our application servers is write these lines of code and these lines of code, and obviously install a monitoring software at first. So here, to sum it up, it's this. And this was all we needed, and all our machines were automatically monitored. I really appreciated it. In addition to these Nagios host resources, there's also a Nagios service resource, so you can monitor your web servers or MySQL servers or whatever service you use. And it's quite easy. We were really talking a lot about resources. I didn't always call them like that, but I tried to. This was a resource, and this was a resource, and this was a resource, and all these resources must be unique. So I can only have one resource of the type service with the name light HTTPD. This is something you really have to understand, and this is the same applies for classes, obviously, and that's the reason why they have to be unique, because, yeah, it's just a resource. And there's actually one way to create resources that can be applied multiple times, and this is the concept of so-called defined types. In contrast to classes, they're allowed to have multiple instances. We kind of already used some there. No, never mind. They are used exactly the same way like the resources that ship with Puppet, like, for instance, the file resource. And I actually got an example again from our real-life code. We have this light HTTPD enable conf defined type, and all it does is create a symlink from a directory where all available configuration files are to a directory where all enabled configuration files are. And yes, there's one important thing. This is the title of the resource. We're going to use that on the next slide, because implementing this defined type is actually quite easy as well. Instead of saying class light HTTPD enabled conf, we say define light HTTPD enabled conf. And then we have this array of parameters, which are optional in our case. We don't have any. And within this defined type, we define a resource and use the title that I mentioned on the slide before. And then we say, like, ensure that it's a link and it points to somewhere, notify the service, require the web server, and so on. Pretty uninteresting. But this is how you can recreate reusable code that can be applied more than once. We can again store these defined types right next to classes in the manifests directory of our modules. When you create defined types, there are some things you might want to take care of. First, we already had this file ensure present resource configuration parameter. If you create defined types, you might most likely want to implement these parameters ensure present and ensure absent as well to be able to delete something. And I mentioned this word idempotency at the beginning, and it's very important that if you create defined types, that everything you do there is idempotent, because otherwise Puppet is going to run multiple times on a node. If something's not idempotent, some weird stuff is going to happen. There's actually a exec resource type which executes something on the command line, and it's quite nice for some stuff, and you really need it when you create defined types. But this is where you really have to take care of the idempotency, because most things you execute on command line aren't idempotent. And I'm going to show you a more real-world and a more interesting example of a defined type right now. And this is replication of a CouchDB database. CouchDB is a very, very awesome database. It's like my favorite database. I always do advertisement for it. It's open source, and you access it using HTTP. So you send an HTTP request there and create a document within the database. It's one of these NoSQL document storages. And also the replication that we want to configure here. We want to replicate the database new logs from some machine to some other machine. And starting this replication is done using HTTP as well. You have to send a post request to some special URL of the CouchDB, and then CouchDB will start replicating. And doing this with Puppet is not really fun. I think I have an example in a second where someone tried something like this. But this is a place where you would really want to start creating Ruby Puppet plugins. But I mentioned before, I don't do Ruby. I don't really like Ruby. I don't want to learn Ruby. That's the most important part. But instead, I want to stick with PHP or whatever. And well, so you have two options if you don't want to do Ruby. You can try and create this within Puppet, or you can create a wrapper script. And if you do something like this in Puppet, you might end up in this in something like this. I took this from a company who I helped cleaning up their Puppet manifests. And yeah, they install a PHP extension here, and they create a couple of resources, all of type exec, and they chain them after each other. And this is quite ugly. I could actually go into detail here, but I'm not going to do that. Instead, I'm going to show you how you could create a wrapper script and access that from Puppet. Getting back to the CouchDB replication, what we did is we created a small script, in our case written in PHP, but it doesn't matter which language you use. And it's accessible like this. I can say CouchDB replication add on this database server, so localhost port 5984, which is the default CouchDB port. This database server should start a replication from this database, which is his own database, to some remote host. Same database name, but other host. And this PHP script does all the magic, like doing the HTTP requests and so on. Also, the script has, next to add, there's also delete or remove, I'm not sure right now. And there's also exists, which checks, is this replication already set up? And then I went and created this simple Puppet manifests, and I shortened it a bit to explain it a bit easier. I created a defined type called CouchDB : replication, and it has the parameters ensure, source, and target. I then create a helper variable called params. I just pass that to the command line script later. And then I do a big switch case and check if case is if ensure is present, then execute create CouchDB replication, and the name is title. It should say title here. I'm sorry. Give this resource just some random name, which is unique. And then I say, please execute CouchDB replication add with the parameters I created up here, unless CouchDB replication exists, has a exit code of 0. So you have to understand the concept of exit codes of shell scripts here. And for absent, it's quite analog. I just give it another name, the resource, and I say only if. So this command will only execute it if this has an exit code of 0. And then I remove it. This is actually a pattern I would kind of suggest to you if you don't want to do Ruby as well. If you say, I already got this cool command line script written in Node.js or whatever. And yeah, I really, really like doing it this way right now because I don't want to do Ruby. I'm running even more out of time than I expected, but that's a good sign because I got questions. I want to get back to the exported resources because they're kind of the auto-discovery of Puppet. And we can use it for replication as well. All our database servers export this CouchDB replication thing, and all of them also collect all of the CouchDB replication defined types. And this automatically set up a replication between all our database servers. So if you have some application running that doesn't do auto-discovery, Puppet will help you here. As we're running kind of short of time, I'm not going to get into detail here. You will get the slides afterwards and can look into it. And also, I kind of cheated in this slide a bit, and there's something missing. But you will have the slides later and can figure out what it means. This talk was called Maintain Your Environment with Puppet, and also said something about how to get production, staging, and development closer to each other. I already introduced you into Vagrant, but I didn't really tell you on how you could make sure that the Vagrant Puppet configuration and the production Puppet configuration look similar. Of course, you can reuse the modules you created. You really want to reuse the modules, but the modules need to be configured in some way as well. And I would suggest creating modules or at least classes. I call them node classes, which aggregate several modules and which pass parameters into these modules and really define how, for instance, your application server should look like. Your application server most likely will need PHP if you're a PHP developer, needs an Apache or whatever web server you have. And this all will be grouped together here. And you really want to use dependency injection here. So if there's any configuration parameter for Apache 2, you want to create this parameter in your node class or role. It's called role in the Puppet world. I didn't know that name before. You really want to inject this parameter through and give you the possibility, for instance, if you have the web server and the database server in your production environment and you use this node class web server, you want to be able to configure the database server in some way. And on your database nodes, if you have this node class database, you want to say which address should the database server bind on. And this will be given through to the MySQL module in this case. So this class uses several other classes, like for instance the MySQL class, and this one uses, for instance, the web server class and the class that configures your application and tells your application to use this database server. And if you now have the staging environment, you would probably change these variables. And if you're in the development environment on the Vagrant node, you will just import both node classes, the database server and the web server, bind on localhost and connect localhost. And this gives you the chance to really reuse exactly the same configuration on production, staging, and environment. Production, staging, and development, sorry. And this is the place where I kind of get to an end and only throw these random words at you. Because we're kind of running out of time, I'm going to skip, maybe going to skip some of them. An important note is when I introduced Puppet to a friend a couple of months or maybe years ago, one concept that he didn't understand is that Puppet is not only for bootstrapping or setting up your server initially, but it's also for maintaining it and changing configurations. So your Puppet files should be idempotent so that they can be run like every 5 minutes or something. We actually run them every 5 minutes, I think. This is something you really want to keep in mind, and this explains why some things in Puppet are more complicated than with simple shell scripts, because these shell scripts you create for setting up a server will only be run once, and if you change something, you SSH into the machine and change it manually. Actually, I know one company who automated this all so much that if you SSH into one of the production servers, there's automatically a ticket created in their issue tracker because it shows them that there's lack of automation somewhere. This is kind of hard. We don't do that, but it might make sense for you. Also, if you write clean Puppet manifests and do something like these node classes I just showed you, the Puppet manifests are kind of your infrastructure documentation. Because if you want to figure out if to which database server an application server talks to, you just check out the manifest of that node and you see, oh, it uses this database server. And if you want to figure out what is installed on a application server, you open up the node class of application servers and you see, okay, every application server gets a light HTTPD installed and gets PHP installed and so on. Many companies don't really document their infrastructure, but if you use Puppet, you kind of have some kind of dirty documentation, at least somewhere. It's better than nothing. This is something important if you create Puppet modules and want to share them somehow and reuse them. A Puppet librarian is something like Composer in the PHP world, or NPM for Node.js, Bundler for Ruby. So it allows you to define dependencies of your module and fetch them from some central source. Also, if you do Puppet, like with any other application that you develop, you want to use automated testing. There is, for instance, RSpec Puppet, and there's also ServerSpec. Just Google both of them. They help you with automated testing. If you are a developer and heard of Solid, when you write Puppet code, please keep in mind that it's still source code, and most concepts of Solid apply for Puppet as well. The guys 2 hours ago explained that as well, and they mentioned that 2 of the letters didn't make sense for Puppet. I didn't really think about which makes sense. I just thought about the concepts and reused them. And reusing is next point. Everything you create should be reusable. Our first light HTTP module was only configuring our light HTTPD for the production environment. At some point, we installed Jira and wanted to use light HTTPD as a reverse proxy and realized, oh, we can reuse the module because it is not configurable at all. And this is something you really want to take care of when you create Puppet modules. If you want to use third-party Puppet modules, check out the Puppet Forge or GitHub. There are plenty of modules out there. A question that many people ask me is, how does Puppet help me with deploying your application? And the answer is Puppet might somehow help you, for instance, by installing Debian packages, by using Pair or Git or whatever, but Puppet is no application deployment tool. We used it as that, and we had several problems with it, so I wouldn't really suggest you to use it for that. Use some other tool like Capistrano. I'm going to skip this one, but I'm going to mention this. When Puppet overwrites a file, you can configure it to always store the old contents of the file somewhere. So if someone manipulated a file on the server and Puppet overwrote it, you can still access the old contents. And you also have some kind of history of the files. I mentioned that Puppet uses HTTP using SSL, and there is some scripts, the Puppet Certificate Authority, which manage all the client certificates, server certificates. It automatically generates them, helps you signing them. It's very, very easy to use. It's just like 2 command line calls that you have to remember, and then it will just work. So you have an encrypted channel there with a certificate authority, and it just works, and it's quite easy. Not going to get into this one. This is an IDE that helps you with developing Puppet manifests. You might want to look it up. I don't really use it, but I heard about that it's quite nice. I tried it. I wasn't that happy. Google this one. Can't explain it. This is an important note. When you like Puppet, you really want to use it for everything. Use it to set up your laptop. It works very well on Linux, obviously. With Boxen, it works quite well on macOS as well. I've got no idea if it works on Windows. Sorry. Another important thing is read the manual of Puppet. Read it over and over and over again. Read all the resource types that are available, because there are so many, you can't keep them in mind, but at some point you're going to realize, damn, the stuff I implemented last week is already available as a Puppet resource type. Happens to me all the time. The manual has gotten a bit better, but it sucked some time ago. But what's really good is the IRC channel of Puppet. There are people in there who really want to help you, and they are nice and stuff, and they answer to your questions. This is something that not many open source projects really do that good as Puppet does it. So this is just a hint. Check out the IRC channel. You also might want to check out SaltStack and Ansible, which are kind of newish alternatives to Puppet. I really didn't look that much into them, but especially SaltStack really looks promising. I already mentioned this one, sorry. Staging is important. You create a staging environment for your source, for your application, and you also want to create a staging environment for your Puppet manifest, because otherwise you might maybe kill your production environment by uninstalling your web server or something. The last thing I mentioned, no, not the last thing, but one thing I mentioned before is version your manifest, put them into Git or whatever, and do continuous integration. I mentioned do automated tests, but as with normal software development, test them continuously. Yes, it's obviously quite easy with Jenkins and these tools. For PHP developers, you might want to check out this thing. It creates you a Puppet configuration and a Vagrant file for PHP, and it's easy to set up and just works. Also, Google this one. It's quite new. It's from the Vagrant developer. It's like the exported resources, but it's way cooler, and it's not Puppet, and it works without Puppet, and works with everything, and it's easy, and yeah, check it out. It's auto-discovery for whatever you want. One last thing. This doesn't apply for this talk only, but for every talk. There's this open platform called Joined In. The organizers of the conference uploaded all talks of the conference there, and you can rate the talks there. It's actually in your interest to rate the talks, because at first, if you didn't like what I told you here, you can write that down and they won't hire me, or they won't invite me again for doing this talk. Also, it helps me to figure out what you didn't like, because you can add comments, especially if you give the talk a bad rating. Describe why, because this helps us speakers to improve, and it helps the conference organizers to improve the conferences and to improve which speakers to invite. So it really asks you to rate all the talks that you attended. Have a safe trip home, and thank you for the attention.